I brought my wrong binder. You guys don't need ACC Geometry 1.
No, can we go over algebra 1, please?
Sure.
I know that's enough.
Same in quadratic formula.
Sawyer, yeah. Listen to Louis Armstrong. Right? I'm not even joking. Listen to Louis Armstrong.
No, lo-fi show. You know how they have like the YouTube 24-hour streams? Lo-fi shows. 24-hour. So good. I'm serious. That's what I'm gonna do. Devin. Whoa. Yeah, you have some.
Okay, I went to the party.
Okay, thank you. Sweet, I was recording the whole time I was gone.
You were recording?
Yes.
Oh, shoot.
Yes. All right, let's take a look at, what is it? The chapter 11 review, right? So is there anything more you'd like me to cover for the chapter 11 review? We got a few minutes. Anything more on the chapter 11 review that you're just not sure about? Even if we went over it yesterday, it's okay. We can go over it again. Yup. 12A. All right. So 12A, this is from the chapter 11 review. This is we want to find the volume and the surface area. Right? And we have, looks like so they tell us that this distance here is 2, this distance here is 10, and this is 14. Okay. So if I want to find the volume of it, I need to find the volume of the two cylinders and subtract them. Is that okay if I say that? So if I want to find the volume of is pi r squared height, and so that'll be for the big, and then minus pi r squared height for the small. Is that all right? How much do I need to work through? Let's see, I get, for the big, I get 100 pi times 14. So that gives me 1400 pi minus pi r squared on, let's see, that's going to be what? Oh, you know what? I'm off. I'm so sorry, I'm off.
Gosh.
So the radius of the big is 5, so that should be 25, right? Times 14. Minus pi r squared, so pi times 1 times the height. I don't know what 25 times 14 is, and I'm pretty sure you could figure that out pretty easily. But once you do, you subtract these from each other and you get the volume. Good? And if you have trouble with double-digit multiplication, then you might be in the wrong spot.
That's what we should go.
I will do the surface area now. All right. So the surface area, I have to realize I have a whole. So let's do this. Let's find the surface area. How many of these do I have? I have a top and a bottom, right? So whatever this is times 2. Okay? So let's find the surface area of the two circles. So that's 1. And that's 5, right? So I have pi r squared minus pi r squared times 2. So I have 2 times pi r squared, so I have 25 pi minus 1 pi. So that gives me 24 pi. So I get 48 pi is the area of the top and the bottom, taking away the little tiny hole that's in the middle. Now I have to figure out the lateral surface area. So I have the inside lateral surface area and I have the outside. So the surface area is going to be 2 pi r times the height, and 2 pi r times the height. 14, sorry. 14. Okay, so this is my big circle, so that's going to give me, I have the radius of the big being 5, so that's 10 pi, right? You all right? Times 14. So that's 140 pi. So that'll be the surface area of all around the whole big, plus 2 pi, the radius here is 1 times 14. So that's what, 28 pi? So that's going to be 168 pi. So that's the whole outside surface and the inside surface. And if I add 168 to 48, if I add these two together, I get my entire surface area. So pretty sure you can go 48 plus 168 and figure that out. What else from the review? Jillian, you had a question.
Surface area for 12B.
12B. Okay. Are you okay with the volume of 12B?
Yeah.
Okay. So I had this cube that has a cone, right? All right. So, let's think about what we have. We have 5 squares that we have to find, and if they're all squares, so I can find that. So I have the front, the back, the left side, the right side, and the bottom that I can use right now that aren't affected by the cone. Agree? So each square is 10 by 10. So 10 times 10 is 100. So I get 500 square units. So that's the top, the bottom, the side, the back, and the front. Does that make sense how I just said that? So now I have this little tiny area up on top that I have to find as well as the lateral area of the cone. Make sense?
Wait, how did you get 500 units squared?
Because so I have a left side, right side, front and back, and bottom. There's 500 of them, and each square is 10 by 10.
Oh, okay.
Okay? Yeah.
So you do 100 minus 5 squared?
I don't know. So whatever my answer comes to once I do the work on top, I have to add 500 to it to get us all the surface area. All right, so this circle, I would say, would have a radius of 5 because the dimensions of this are 10 by 10 by 10, right? Okay, so I know the top is 100 minus pi r squared. So that's 100 minus 25 pi. Okay, so that's the area, this little area up on top that the circle is not competing with. Is that okay for me to say that? So that will be added to that 500 here eventually. And then I have to find the surface area of the lateral area of the cone. So I have a height of 10. So that's 5, that's 10. I have to find L. Pythagorean theorem is going to work to find L because I need to use pi RL to find the lateral area of that. So 25 and 100. So this is going to be root 125, I believe. Did I do my math right? Which I can break root 125 down to 25 times, so 5 root 5. That's L. So if I use pi RL, That's going to give me 25 root 5 pi square units. So that's the lateral area of the cone. So now I have to add up everything I have. So I'm going to add 500 to 100, so I get 600. And then I have 25 pi, so minus 25 pi plus 25 root 5 pi. So that whole thing is my area. I don't know, did it ask me to do? So 12b, 600, we agree, minus 25 pi, we agree, plus 25 pi root 5. Sweet, it worked. Does that make sense? Yeah.
Yeah, does it matter if you put the pi at the end or after the 25? Because like that has it 25 root 5 pi, and then the answer has it 25 pi root 5.
Oh, it doesn't matter. It's like a times b times c. It's the same as a times c times b. So yeah, I'd accept it either way. That's a good one. I like that. Unit squared. Yeah.
Okay, I think I can answer this way, but is there going to be a problem like number 9?
Yeah. Well, let's take a look at number 9 again. Cool. Okay. So I mean, I'd hate to say no, it's not going to be there, and all of a sudden you're like, oh, he's a big jerk. All right. So the person is 6 feet tall and weighs 220 pounds. And then some reason he shrank to be 3 feet tall. So we want to know how many pounds this is. Okay, we have to understand that the height is a linear length. So it's the first dimension. Pounds are a volume, so it's a third dimension. So I'm looking for pounds. So what I should do is I need to convert this and this to 3D. So that's 216 over our other mass equals 27 over question mark. And cross multiply, and that'll tell you how many pounds. Now, the only other way this problem would have been done is let's say this is not on your sheet. Disclaimer, this is not on your sheet. Let's say we're trying to figure out how tall he is if we know that he is 70 lbs or 70 pounds. So in this case, I would actually have to do 6 over the third root of 220 is equal to question mark over the third root of 70. Now, if we have something like that, these would probably be perfect cubes to happen. On this, on your calculator, you'd have to go 220 raised to the 1/3 power, or find the third root on your calculator, and then 70 raised to the 1/3. So again, a disclaimer, this is not on your homework. This is just showing you sometimes you have to cube your linears or take the cube root of your cubes to go backwards. Yeah?
Could you do it like with x cubed and solve for x and do it at the end?
It doesn't really work as no, because order of operation, and this is why. Think of order of operations. Exponent happens first. So if you cross multiply and then cube, you change your order of operations. Okay, order of operations, take care of exponents first, then multiply. Don't multiply and then do exponent. Okay? Yeah.
Okay, so to the first power is like linear, right? To the second power is like,
Surface area.
yeah, third power volume.
Uh-huh.
What would the fourth power be? Or is it?
Well, we have, theoretically, there's no limit on how many dimensions we have. Just
Do it again.
a cheap dimension would be thinking about time. Right now, time is a half dimension because we know how to move forward in time. We don't know how to move back in time. So right now, could say we're in the 3.5 dimension because we don't know how to go backwards in time. A dimension is something you go backwards and forwards in.
Yeah. So, what, like, okay, so if you had like a problem that was taught, like your answer would be in the fourth dimension, what would that look like? Like, what would you be asking?
I can show you what the shadow of the fourth dimension looks like in 3 space, but I can't show you what the actual object would look like in 4 space. It's like we can't see it visually. We can only see the shadow in 3 space of what a fourth dimensional object is. So theoretically, we're all shadows of some higher dimension. Then you can get all this weird, you can bring religion in if you want to go real goofy with, public school, which I'm not going to do.
Okay.
Yeah.
Is there weight in 2 dimensions?
Weight in 2 dimensions? No.
Yeah, why is weight in the third dimension?
volume.
But like weight is just like volume. Because like when you find the volume of like a cylinder or something, that's not how much it weighs.
It would depend upon the liquid. So like,
But it's not the weight.
right, so it's a
It's like how much
3-dimensional,
space
but you
it's
can
on.
convert it to. So that takes you to a whole different chemistry outlook on stuff, figuring out what the molar masses of stuff. Which I'm not going to go with you guys. All right, are we solid with? So we have. I'm going to hand this out. This is optional. This is the answers to this. In the other geometry classes, they're doing something cutesy, and I'm sorry, I'm not. They're doing the scavenger hunt thing. I decided to print up the worksheet and have the answers on the back. So if you want the scavenger hunt, you can go to one of the other geometry teachers and do the scavenger hunt. Yeah, you can leave. So the answers I put on the very back. This, if you feel okay about it, would might help you towards the test tomorrow. The test tomorrow is all multiple choice. Yes, you can use your calculator. Yes, you can act like you use your neighbor's paper next to you. But we're going to have 4 different versions of the test, so your neighbor might not have the same test as you.
Wait, 4 different versions?
Yeah. We have the Sawyer version, and everyone else has a different version.
So you won't be surprised when all of my answers are wrong.
All right, so this is just review. If you wanted to do this, awesome. This is not required, but it might help you along with the test. Again, the answers are on the very back page if you want to see that. So I wanted to, if it's okay with y'all, go and so let's talk about, was there anything from the semester review 1 that I didn't cover enough that you wanted to re-go over from the semester review 1? Semester review 1. Yeah, number 8. Okay. So this is from semester review 1, problem number 8. It's wait, I didn't. Oh, I can't draw this to save my life. That one, right? Okay. So let's take care of y first. So if I go this to this, I'm going to get 6 over 10 equals this to this. So then that's equal 15 over y. Cross multiply, so I get 6y is equal to 150. Y is equal to 25. Is that right? Is that okay so far? Okay. And then we want to find x. So let's realize that this portion right here, if this is 5 and the whole thing's x, then this is going to be x minus 5. Is that okay for me to say that? Okay, so then let's go 6 over x minus 5. So small equals 15 to what? X, good. Okay, cross multiply, so I get 6x is equal to 15x minus 75. Is that right? Subtract, so I get negative 9x equals negative 75, so 9x equals equals 75. So x is equal to 75 over 9, which reduces to 25 over 3. I guess if you want to get all fancy and not good math students, you could say 8 1/3. So I'd say 25 over 3 is x. Anything else from review 1? Yeah. 14, review 1. Okay, let's see if I can draw this. That's 3, that's 4, that's 5, that's 3, that's y, that's x, that's y. Okay. Bless you. Okay. So let's figure out, we'll figure out y first. So I'm going to go 5 over 3 equals 9 over y. Cross multiply, I get 5y equals 27, so y equals 27 over 5. Is that all right? Similar shape. Can I go? That's what I was trying to think. Does it have to? I go similar. So maybe I can go. Maybe I can go 3 over 5 is equal to 4 over x. I don't know, is that going to work? 3x is equal to 20. X equals 20 over 3. Is that even close? Oh, cool. Okay. Oh, I went this 3 over this 5, this 4 over this x. I could have went 3 over 4 equals 5 over x. That would have been, so that would have been the same thing. Watch. So 3 over 4 equals 5 over x. 3 over 4, 5 over x. So then I get 3x equals 20. Still going to come out the same thing. All right, are we good with review number 1? Can we move off of review number 1? We'll reserve very little time for review number 1. Review number 2, we talked about it a little bit yesterday, first time. Is there anything on review number 2 you want to take a look at? Yeah. Number 2. Solve for x. This is review number 2. Yeah. You're good?
Yeah.
Anyone, everyone else good on number 2? Pythagorean theorem works. I guess the main thing to realize on Pythagorean on this one is this. So you have root 6 squared plus 2 root 3 squared equals x squared. So you have to remember so that's 6 plus 4 times 3, so that's 12. Does everyone see why I get 12 there?
Yeah.
Okay, the reason is I have 2 root 3 and 2 root 3. So you multiply root 3 times root 3 to get 3, 2 times 2 to get 4, so 4 times 3. And then that equals x squared, so that becomes x squared equals 18. X equals root 18, which is 3 root 2, I believe. Cool? Guess what? 7. All right, a couple ways you can look at number 7. If you remember the geometric mean, you could realize that x is the geometric mean of 6 and 4. I'll say that one more time. X is the geometric mean of 6 and 4. Okay? So that would mean that 6 over x equals x over 4. So x squared equals root is 24. X equals root 24, which is 2 root 6. Okay, now that's in this case. That's realizing, hey, we're looking for the geometric mean of these two. Okay, I think the other way you might approach this is you might have to start realizing there's 3 triangles there that are all similar that I have to take apart. Okay, but if I automatically am able to find that, can I find y by using the Pythagorean theorem? Yeah. So all of a sudden, if this is 2 root 6, there's my right angle, I get 2 root 6 quantity squared plus 4 squared equals y squared. So that's 4 times 6, that's 24, plus 16 equals y squared. So y squared equals 40. So 2 root 10? Yeah. Cool. So that, and I'd say if we have it reviewed that way, that might be a great way to see it. So you realize x is the geometric mean of 6 and 4, and you go from that. Yeah? 20. A 12-foot ladder meets a wall 11 feet off the ground. What is the angle formed by the ground and the ladder? Okay. So you have this wall, you have this ladder leaning against the wall. You have to realize that forms a right angle. So here's my ladder. Right? The ladder itself is a 12-foot ladder. And it meets a wall 11 feet up. So what is the angle formed? What is the angle formed by the ground? This is the ground. So we'll call that x. So that looks like opposite and hypotenuse. Opposite and hypotenuse is sine. So I have sine x equals 11 over 12. So then I have to do second sine. Good, to find the angle. The second sine of 11 over 12. Make sure your calculator is in degree because it'll give you a radian answer. Huh? 66.44? Well, if you're getting hot, you're all humid. I realized last teacher puts the heater rag on. I'm like, man, I got a fever or something. I'm not feeling it.
Heater rag?
Huh? My do-rag? What? What's my do-rag? Anything else from review number 2? Take home final. You got it. Yeah. 7. 17. Oh, I got you. Did we do this one yesterday?
Yes.
I'll go quick through it.
Oh, sorry.
No, you're okay. I'll go quickly through it, though. So if this is 21 degrees, this is 17 degrees, and we know that the height is 50. Is that right? If we want to find x, we have to realize I have an unknown and I have a smiley face unknown. Is that okay? So I'm going to look at both triangles. So this, in relation to this triangle, this is the opposite and the adjacent. So that's tangent. So I get tangent 21 equals question mark over 50. So I get 50 tan 21 equals question mark. So you find that on your calculator. And then on this one, if I look here, I have the opposite and adjacent. So then I have tangent 17 equals smiley face over 50. So then 50 tangent 17 equals smiley face. And if I add those two together, that would solve for me x. Anything else from review number 2? Again, we'll have some more time to focus on that on, I guess, Thursday. So I want to turn the page to review number 3. Review number 3, this is starting to be stuff that's not too far back, but sometimes it's easy to forget about. Is there anything on review number 3 that you would like to take a look at? Yeah. Number 1? Number 1. So review number 3, number 1. All right. Find the sum of the interior angles of a nonagon. Nonagon's 9-sided. So if I wanted the sum of the angles I'm going to use n minus 2 times 180, and that'll get me the sum of all the angles. So I'm going to go 9 minus 2 times 180, so that's 7 times 180. Whatever that comes out to would be all of it. And then realize if you divide that by n, you would find if it was regular nonagon, what each individual angle would be. Yeah?
Never mind you.
Okay. Yeah. Who? 2. A regular polygon has interior angles with measures of 40 each. How many sides does it have? Okay, so number 2, we have a polygon. So each individual angle inside is 40 degrees each. Okay? So how many sides does it have? Okay. So we have to understand n minus 2 times 180 divided by n is how I would get to that 40. Is that okay so far? So let's move that over, distribute, so I get 180n minus 360 equals 40n. Is that okay? Subtract 40n, so that becomes 140n over here. Move the 360 over. And this one's not going to work. How many? Regular polygon has an inch,
That's the
Is that what the answer says?
Yeah.
Oh, good. Oh, good. All right. Yeah, this wouldn't work because that has to come out to an even number.
How many of those are
Oh, I don't know. I'm just glad I got the answer right, and then it's like, no, it's 6.
better not have any no cost.
Yeah.
What's the thing for
For what? Ooh, diagonals. What was the diagonals? Diagonals. Which one are we looking at? Hexagon. All right. I would think 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5, 6. Diagonals does this. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, and that's it?
No, there's
Wait,
one more.
No, there's one. You gotta, yeah, that one to the left. No, to the left.
Here.
Yeah.
How many does that make? 10?
9. It's 9.
Give it how you figure.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I have 9.
Like a bunch of stars. It's weird.
I would say, rather than worrying about the equation, I don't remember it. I know there was an equation we came across. What is it?
Who's the upper end?
N minus 3 over n.
N minus 3 over n?
Yeah.
N minus 3 over n, let's see.
No, it's like
N times n minus 3.
yeah,
N times n minus 3
over 2.
over 2?
No?
Well, let's see. That's it?
I'm right.
Over 2?
Yeah, he's right. Yeah.
So that was so that's 6 times 3 over 2, 18. Yeah, 18. There you go.
Let's go.
So,
That's the
if you remember that equation, awesome. If you just drew out your shape, you started doing connected dots. Either way, I'm not going to know. Especially because it's multiple choice plus.
That was the peak of my school career.
That was it. You nailed it.
Downhill from here.
Yes, ma'am.
So you use the n minus 2 times 180 to find the sum, and then you divide it by n to find an individual angle.
Right, if it's a regular polygon. It doesn't have to be a regular polygon to find the sum. Okay. Yeah.
Can you just remind us how to use 4? Like, I know you add them, but what do you?
4. All right, so it's 1, 2, 3, 4, 5. So it's a 5-sided object. So 5 minus 2 times 180. That should come out to 540 degrees, right? So then you have to add up all your angles. So you have 110, 55, 145, 90, and x minus 35. And if I add these all up, they have to equal 540. So anyone have a calculator that we can utilize real quick? Ready?
Yeah.
110 plus 55 plus 145 plus 90 minus 35. 365. And then plus x. So then I'm going to subtract 365 from both sides. So I get 540 minus 365.
175.
Sweet. That'll work. 7b. I'll probably have to do 7a as well. Alright, number 7. The what?
Exterior angles are always
360 exterior angles. So the exterior angles I always have to add up to 360. So you go 110 plus 120 plus 70 plus x plus 2x equals 360. And that's all from there. So number 7. We have a rhombus. What things do we know about a rhombus?
Oh, they're funny.
They are funny. Good. Not sure that's the math we're looking for, but hey, we'll take it.
Square.
We have this rhombus. It's a crooked square. These obviously cut each other like that. Other things about a rhombus, I believe those are all 90s. Is that right? Is there anything else that we need to know? So we know that A to C, so from A to C is 18. So this is 9 and this is 9. And B to D is 24. So this is 12 and this is 12. So find the perimeter of ABC. That's a 3, 4, 5, isn't it? In disguise, right?
Oh, so 8.
3, 4, 5. So 3 times 3, 3 times 4, 3 times 5. So that's 15, 15, 15, and 15. So that's the perimeter is 60 units. Is that okay? 7b. Find the measure of BAC. Find this measure, BAC. That measure right there. Oh, okay. So if I'm going to call that x, I can do a number of things. I could do sine x equals 12 over 15. I can do cosine x is equal to 9 over 15. I can do tangent x is equal to 12 over 9. You pick, same answer either way. Remember, how do I find the angle? What do I have to do with the calculator?
Second. Wait, so you do second sine equals 12.
Uh-huh. Or second cosine equals 9 over 15. Or second tangent equals 12 over 9.
Second sine.
You?
No, I mean,
What? 10?
10.
10.
Second sine.
10. Here he comes. MNOP is a square. Find x and the perimeter. So they tell us that this is a square. They tell us that's 2x plus 1. And they tell us that this angle here is 2x plus 25. Ready? So if this is a square, what can you tell me about this angle? 45. So I get 2x plus 25 equals 45. Subtract 25, so 2x equals 20. X equals 10. If x equals 10, that means this is 21, 21, 21, 21. Find the perimeter of the square. 84. Perimeter is equal to 84 units. Yes. 14. We got a kite. What do we know about kites? They fly in the sky. Good. What else do we know about them? They're weird. They're weird. Okay. We have this kite. We know this is 15. We know this is 110. We know this is 30. Okay, things that I have to know. If that's 15, this has to be 15. If this is 30, this has to be 110 because they diagonals. Oh, I could do that. So that's 40, right? It's 40 up there, right?
Yeah.
Okay. So then that has to be 30 over here, and that has to be 40 up there because those cut each other in half. Find BC. Find B to C. Oh, we did. We already found it. And the measure of ADC. So we found BC. It's right here. ADC. So what is this angle? Well, that angle has to be 60 degrees. And ABC, oh, that has to be 80 degrees. All right, so, guys and girls, what do you think? So, so tomorrow is Wednesday, right?
Yeah.
We have the Chapter 11 test. It's multiple choice. So yes, you can use a calculator, it's multiple choice. Thursday, I have any quick questions on 1 and 2, but I don't think we need to spend too much more time on that. We can spend a little bit more time on 3 and really focus on 4 and maybe even start into 5. And then Friday, we'll be covering 1 through 6 as much as we possibly can. Yo.
Mr. Stewart, I just found out how long it would take to travel the entire surface area of the planet at maximum achievable velocity of the human race. It's only 29 days.
29 days?
Yeah, because if you account for how long it takes to go to Mars,
Yeah.
and the distance and the time, then you feel like if you divide this and you get the velocity, that's the maximum velocity that human race is able to achieve. So in the planner, it also has in the back the diameter of the planet Earth. So I took that and I found the surface area of the entire planet and I divided that by the velocity or something like that. And I figured out it only takes 28.77363767 minutes